All right, day 9. Homework is to study for the test tomorrow. First one on the homework, when you do your change in y over change in x, should have got 2, 4, 8, 16, 32, 64. When you divided y2 divided by y1, you should have got 2 for each of them. So that's why this is 2, because the successive ratios were 2. And then because at our x value of 0 we had 2, that's why the front one is 2. So different reasons for each of those 2's. The next one, our slopes were all 3. Our successive ratios, you can see what they are there and compare them to what you have. So because the slope was 3, that's why 3 is in front of our x. At x equals 0, we had 2, so that's why we have a plus 2 afterwards. And our last one, our slopes were 2/9, 2/3, 2, 6, 18, 54. When we do y2 divided by y1, and you might have wanted to do that with your calculator for the fractions, but you get 3 each time. So because that was 3 each time, it's exponential. We had 3 for our base, and the 1/9 was out front because of the 1/9 that corresponded to x equals 0. So we're going to start on page 21. What I would suggest to maybe do as you're doing this is to pause the video, see if you can do a question, and then if you get stuck or when you get to the end of it, hit play and then see if you did it correctly. That would allow you to test yourself as you're going through it. So it's up to you whether you do that or not, but I think that's the best way that you can make sure you're studying for the test. So in this first one, we'll have our change in y over change in x and our successive ratio. So we got 1.5 minus 0.5 over 1 minus 0. So that will just give us 1. Then we'll do 4.5 minus 1.5 over 2 minus 1. That gives us 3. As we carry that on, we'll get 9, 27, and 81. Our successive ratios, if we do our y2 divided by our y1, we get 3. And then the next one, when we do 4.5 divided by 1.5, we get 3. And that should carry on all the way through. Because the successive ratio is the same, that tells us exponential. We'll have y equals something times 3 to the x. And to decide that something, it corresponds to when x is equal to 0. So we would have a 0.5 out front. Now you could always put in your calculator in a graphs page, y equals 0.5 times 3 to the x, do a control T, see if your table matches the table that's there. Similar idea here, we're doing y2 minus y1 over x2 minus x1. This will give us negative 2. Then we'll do 3 minus 5 over 3 minus 2, which will give us negative 2. And we would find that we get negative 2 for each of them. Successive ratios, we would have 5/7 when we do y2 divided by y1. Then 3/5, then 1/3, then negative 1, and then 3. And again, that's doing y2 divided by y1. Because the slopes are all the same, that would lead us to know it's linear. And we'll have y equals minus 2x because the slopes are negative 2. And our b value should be when x is equal to 0. But notice we don't have x equals 0 there. So we got to follow our pattern going backwards. 3, 5, 7. So at 0 then it must be 9. So we should have plus 9 on the end. No shifts left or right here, so in our table we would want 0 as the middle value. 1 and 2 would come after it, negative 1 and negative 2. When we sub in 0, we'll have 1/6 times 3 to the 0 minus 4. That's 1/6 times 1 minus 4, or in other words, 1/6 minus 4. I'm just using this as a number line. If you're at 1/6 and do 1, 2, 3, 4 to the left, we are now negative 3 and some fraction. When you cross over the y-axis, it shouldn't be that same fraction. It should be its opposite, so we'll have negative 3 and 5/6. If we switch and try 1 now, this would be 3. 3 over 1 times 1 over 6 would give us 3/6, which is 1/2 minus 4. Well, similar idea, if we're at a half and go 4 to the left, we'll have minus 3 1/2. And the only reason that fraction's the same is it's a half's opposite. It also just happens to be a half. We'll put in the 2 now. 3 squared is 9. 9 over 1 gives us 9/6. And that you can either think of it as 3/2 or 1.5. And 1.5 minus 4 can either give you negative 2.5 or negative 2.5. As we move to our harder ones now, when we put in negative 1, 3 to the negative 1 gives us 1 over 3 to the first. That's going to give us 1/18 minus 4. And we can use the same visual. We're crossing over the y-axis. So we're going to have negative 3, and this would be 17/18. And then our last one, if we put in negative 2, that's going to be 1 over 3 to the positive 2. So this will be 1/6 times 1/9 minus 4. Oops, I don't know why I wrote 9/9. 1/9. 1/6 times 1/9 is 1/54 minus 4. And we can use the same visual. We're moving 4 to the left from that tiny number. Crosses over the y-axis. So this is going to be minus 3 and 53/54. So we'll actually graph this now. When we graph it, we want to make sure we have arrows on our axes. Label your x and y. We've got negative 2. Negative 3 and 53/54 is just almost negative 4. Then we'll have negative 1 and negative 17, negative 1 and 17/18, which is almost negative 4. Negative 3 and 5/6, negative 3.5, and then negative 2.5. Sketch it in with a nice smooth curve. It should be flattening out at negative 4, and just label your equation. So that would be considered kind of a challenging one. For the next one, we've got a shift left 2. So in our table, we would want minus 2 as the middle value. Negative 1 and 0 are the two bigger. Negative 3 and negative 4 are the two smaller. So start with your middle one. 2 times 1/4, negative 2 plus 2. That's 2 times 1/4 to the 0. Or in other words, 2 times 1, which is just 2. If we switch that 0 now or negative 2 now to a negative 1, we'll end up getting 2 to the first. So this is 2 over 1 times 1 over 4. When you multiply straight across, you get 2/4, or in other words, 1/2. We'll switch this to a 0 now. So we'll get 2 times 1/4 squared. So that's 2 times 1 squared over 4 squared. That's 2 times 1 over 16. When we multiply straight across, that'll give us 2/16, which is the same as 1/8. When we put in negative 3, we'll have a negative 1 in the exponent. So this will become 2 times 1 to the negative 1 over 4 to the negative 1. Negative exponents switch where they are in the fraction. So this is 2 times 4 to the first over 1 to the first. 4 to the first over 1 to the first is just 4. So 2 times 4 will give us 8. And our last one, if we put in negative 4, this will now be negative 2, meaning these are each raised to the negative 2, and meaning these are each then squared. So now we're going to have 2 times 4 squared, which is 16, over 1 squared, which is 1, and 2 times 16 will just give us 32. The 32 isn't going to fit on our graph, but we should be able to fit our other ones. I'm going to put my x-axis kind of low so we can fit in the 8. So we have negative 3 and 8, negative 2 and 2, negative 1 and a half, and 0 and an eighth. Make sure you got arrows. Make sure you label your equation. So again, the best way you can be doing these is to pause it, try it on your own, and then hit play to see how you did. So here we're leveling off at 0, so our base equation is just a times b to the x. We'll fill in our x's and y's, so we get a equals a times b to the 4, and we'll have 2 equals a times b to the third. Divide your equations, bigger exponent on top, so we'll have 2 over 4. Oops, I made a mistake there. Bigger exponent was 4 in this case. So we'll have 4 over 2 is equal to ab to the fourth over ab to the third. 4 divided by 2 gives us 2. The a's divide out. We'll end up with b to the first, which is just b. And I'm going to plug back into this one. So we'll have 2 equals a times 2 to the third. 2 times 2 times 2 is 8. And divide by 8. 2 eighths gives us 1/4 for a. We didn't have to worry about adding or subtracting anything on the end, so we just have 2, oops, sorry, I reversed that. We have 1/4 times 2 raised to the x. Number 6. Our base equation would be a times b to the x. We're flattening off at negative 3. So we'll fill those each in. We've got 5 equals a times b to the negative 1 minus 3. And we've got 1 equals a times b to the 0 minus 3. If you're adding or subtracting on the end, get rid of that first. So we'll add the 3 over for both of them, giving us 8 equals a times b to the negative 1, and 4 equals a times b to the 0. Bigger exponent on top, 0 is larger than negative 1, so 4 over 8 is equal to a times b to the 0 over a times b to the negative 1. Divide on the left, we get a half. The a's wipe out, and be careful of your exponents. 0 minus a negative 1 really is a plus 1. So this is just b to the first, which is b. Sub back into your 0 equation, because that's easier. So we'll have 4 equals a times 1/2 to the 0. Anything to the 0 is 1, so this is 4 equals a times 1, or in other words, a is just 4. So our final equation, we've got y equals 4 times 1/2 to the x, and don't forget your minus 3 on the end. It's a common mistake people make, forgetting to put that plus or minus thing on the end. So our last thing we're going to look at, there's not a spot in your packet, so you can put it on front of the packet, back of the packet, wherever you have space. You can put it on a separate sheet of paper. We're going to look at a synopsis of each of our transformations. So we're going to start everything from y equals 2 to the x. And I would suggest copying these down and studying them tonight because you will have to apply them. So from y equals 2 to the x, our x-axis reflection, we negate the out front, the y spot. So we have y equals minus and then times 2 to the x. The y-axis reflection, or in other words, reflection over the y-axis, we would negate the x spot, so y equals 2 raised to the negative x. So again, putting this wherever you have space to help you study from it. Our shifts now, we have 4 shifts. So again, we're starting with y equals 2 to the x. So let's say we want to go up 3. So we'll have y equals 2 to the x plus 3. Let's say we wanted to go down 4. Well, then we would have y equals 2 to the x minus 4. Up and down are exactly what you would think. Right and left are not. Let's say we wanted to go right 7. We would have y equals 2, and in the exponent we'd have x minus 7. Because it's opposite of what you think in the exponent. And if we went left 6, we would have y equals 2, and then x plus 6 in the exponent. So lastly, our vertical stretches and compressions. So again, we're going off of y equals 2 raised to the x. Vertical stretch, we should multiply out front by a number bigger than 1. So let's say y equals 4 times 2 to the x. So that number out front just has to be bigger than 1. And if we had the vertical compression, we would need a number out front that's less than 1. So anything between 0 and 1 would cause that compression. If it was a negative fraction, it would just be a compression and also have a reflection over the x-axis. So make sure you study those. You will have to use them on the test. Have a great rest of your day, and make sure you're studying each of the things in this video for the test next class.